approximate the limit of this, x minus 4 over x squared minus 16, as x approaches 4. So you can see if you plug in 4 into x here, 4 squared is 16, 16 minus 8, it gives you 0 on the bottom. And we can't divide by 0. So we don't know what this is directly. But one way of figuring it out is you could use a table. So I'm going to make a table with x values in the first column and x minus 4 over x squared minus 16 in the second column. So I'm going to choose x values that approach 4 from the left and the right. So if you think about a number line and you're approaching 4, you could go, let's say 3.99 and then 3.999. That gets really, really close to 4. And if you approach it from the right on the number line, you could go 4.001, 4.01. So I'm approaching 4 as if you were on a number line. So what I'm going to do here is I'm just going to plug these x values into the function there and get values over here on the right. So if I do 3.99 minus 4 divided by 3.99 squared minus 16, I get 0.12516. If I plug in 3.999 minus 4 divided by 3.999 squared minus 16, I get 0.12502. I'm rounding it to the 5th place there. If I plug in 4.001, I get 0.12498. And if I plug in 4.01, I get this number. If you try to plug in 4, then the calculator will just give you an error message. So we're trying to find the limit of this function as x approaches 4. So you can see as we're approaching it, if you go halfway between these two numbers, you get 0.125. So I'm going to assume as x approaches 4 that it's going to converge to this 0.125 number. So the limit as x approaches 4 of this function is going to be approximately 0.125.